took a different quiz, just so you know, so I couldn't show like any version. They're all very different. So this is just an example. So every one of you had to define arrays. So it's the first step in the quiz. So I'm looking for you to know that you need square brackets, that you need curly brackets for cell arrays, commas, and semicolons to distinguish between rows and columns. Then you needed to access particular sections of an array. So remember that you use the row, column, index notation. So 1 would mean that you're accessing the first row, and colon in the second element would mean all of the columns. So that would in turn do the whole first row. If it was reversed and it was colon, comma, 1, it would be the first column, and then you can pull out single elements as well. You were asked to do some operations on arrays. So most of you had to do either like a max or a min or a sum or some variation of that, where you have to put in the array into the function and take out information like its value and location. One of the more tricky parts of the quiz was adding a row or column to an array. And so to add something to an array, you just access what you would like to add. So if your array only had 2 columns and you wanted to add a third, or 2 rows and you wanted to add a third, you would just access the third row, all columns, and then just define it to something, and then it will add that. And that was something that wasn't in the lab, but that was in lecture. And then displaying. I think we're good at displaying now, but we'll keep doing it until we have some plots to do. But basically combining numbers and strings in a display statement using display, disp, or fprintf. Okay, so plotting is the topic that we're just finishing up here, that you're going to finish your lab next week and then take the quiz on it. The quiz, by the way, is going to be just like the lab, where I'm going to give you a figure and you're just going to recreate it. So there's not going to be a bunch of language that's going to describe what you need to do. You just need to do it. So you'll get some data that you'll download from D2L and you'll plot it. Okay, so that's what you can expect for that. As far as what you should be comfortable with, everything in the plotting handout is what you can expect on the quiz, that type of customization. So titles, axis labels, changing tick marks, plotting multiple lines on a single plot, stuff like that. Some of the more bizarre stuff, like changing the color bar and taking the edge color off a contour, that stuff's not going to be on the quiz, but I'm sure you can all figure out how to do that stuff through the help. But I'm looking for more of the standard customization. The handout on D2L. But they kind of have the same. One just explains more than the other. Okay. And just so you know, plotting, like I said, I can't tell you all of it. What I need to tell you is what I need you to learn is how to determine all of the customization, because I don't remember it myself, right? You just go and look up the syntax. A couple of things that I've noticed that would be really helpful to just highlight is to type close all at the top of your file. That will always close all of the active figures and open up new ones, so that when you run your file, the figure will pop up rather than having to go backwards through Windows to find the figure. And then the second thing is I wanted to just talk about the set command one more time. I feel like it's one of the plotting things that people find most magical and least understanding, which is fine. So the set command has 3 inputs. The first is you need to tell it what you're trying to change. So GCA means I want to change the active figure or the active axis. So GCA means active axis and GCF means active figure. Depending on what you're trying to change, you will adjust that. Like if you want to change the background color of the figure window, then you would use GCF. But if you're trying to change tick marks on the axis, then you would use GCA. The next input is what we call the property name that you want to change. So you have to go in and look at how to do that. I'm going to show you that when I move over to MATLAB in a second. So basically you're going to look up the thing that you're trying to set. So if it's a plotting feature, you go to the plot help. If you scroll all the way down to the bottom, there's always something called properties. And if you click on that, you can find all of these different property names that can be changed. And then the third is the property value that you'd like to change to. So this is saying I want to change the ticks to be 1, 2, 3, 4, 5. For Xtick labels, it's usually a string of us saved into a cell array. So this is just taken from the plotting handout, what I changed it. All right. I'm going to move over to the DocCam for just a little bit, and then I'm going to show you a bunch of stuff. This topic is, I like to say that there's there's 3 topics that are basically the foundation of the programming aspect of the course, and this is the first one. So logic is the first one, loops is the next one, and then functions is the next one. So those 3, the most difficult and the most important. So take time now to understand this stuff. It will really help you as we move forward in this class. So, I don't know why this isn't working. Oh, got it. Okay. So what we're going to be doing today is introducing the concept of logic and how you communicate logic with MATLAB. So, sorry, this is not working. Just one second. I'm just trying to set up the recording. It doesn't seem to like this. So the first thing that we need to look at when we are starting to think about logic is a new class of variables, or a new kind of like class of data in MATLAB. And it's called the logical class. And this is what MATLAB uses to represent true and false values, which is what we use in logic. And so we call that a Boolean data type. Yes. So the way that MATLAB saves true and false Boolean data type is with a 0 and a 1. So 1 represents true and 0 represents false. And just to motivate what we're doing here is anything that you want to kind of develop as an algorithm in a programming code somehow needs to use logic. And logic is the way that you allow the computer to make decision-making statements. So that's what we're kind of going to explore in this topic. And there's a couple different things that we need to start looking at in order to do that. And some of it we've actually already played with a little bit because you can't do much without these, and so we've already kind of used them without really knowing exactly what we were doing. So the first is relational operators. So these are always used in logic statements in order to relate conditions. So the way that you can think about relational operators is that they're used to ask questions, but they can only answer true and false questions. So as we start developing algorithms, everything needs to be converted into a question that's either true or false, yes or no. And so the relational operators, I'm going to just go through them and give you the syntax, are just greater than and less than. And this seems really obvious, but some programming languages do not use those symbols. They use like LT for less than and GT for greater than. There's a lot of different syntax for this, but this is MATLAB syntax. They use the symbols. One that is universally confusing for first-time programmers is equal to, because we use the single equal sign for variable definitions, and it's reserved for that. So if you need to compare two things to see if they're equal to each other, you have to use two equal signs. Then there's a few more. Greater than or equal to. Is another one, and that uses the greater than symbol and the equal symbol next to each other. Same with less than. And then, does anyone know what the last one is? Yeah, not equal is the last one. So in MATLAB, that's the tilde or the squiggly and the equal sign. A lot of languages use the backslash and the equal. And as you kind of move through your coursework, you'll see different languages, especially for like data acquisition tools and stuff like that. And those they'll have all these, but they'll use different syntax. So let's just talk a little bit about how this sort of operation works in MATLAB. I'm going to write these ones and not type them, but when I do the next one, I'll move into MATLAB and show you. So basically, a logical class is a way to give a response to a relational condition. So if I typed in 5 less than 3 into MATLAB, this is verbatim what you would type, 5 less than 3, that is a relational condition that is not true, right? That is false. So the output of typing that into MATLAB would be 0. So by default, when you give a relational condition to MATLAB, it outputs a Boolean response of 0 or 1. This seems weird, like why would you ever do that? You will. Just hang in there with me for a minute. Let's just do another one. So if I did some operations, so if I did 5 plus 2 equals 7, that's another relational condition, but that one is true, right? 5 plus 7 is 7, so the left and right hand side are equal, so that's going to respond with a 1. So what we're often doing is we're setting up these relational conditions with arrays or variables and checking to see if those conditions are true, and if they are true, then we usually have the code do something. And so we'll talk about that in a second. Before I move on, I want to talk about the second kind of operator that we need for logic, which is called a logical operator. So relational operators pose questions, and logical operators are a way to combine multiple questions in a single logical statement. So they're used to combine relational operators. So for example, you could have one condition, and then you want to see when that condition and another condition are true, or when that condition or another condition is true. So this brings us to a topic of general logic that, depending on the background that you've had, if you've taken a logic class or you've seen this in a math class, this might be new for you. I don't know. So this is the way that logic reads in a computer. So if you have a Boolean operator that's true, and you put in an AND logical operator with another true statement, another Boolean operator that's true, then what's the output of that? Is it true or false? That's true. If you have an AND statement combined with a true and a false statement, is that going to be true or false? That's going to be false. So the and means that if they're both true, then the output is true. If one of them is false, then the output is false. So the alternative is the or. So the or is going to check if either is true. So if they're both true, it's still true. But even if only one of them is true, the output is still true. If this sounds like just a bunch of gibber jabberish, that's fine. I think you all know what and or means, and that's all you need to know, okay? So you just have to be able to create an algorithm with these two statements.
Does it work for like two false as well?
Yes, they're the same. Yep, for false and false. So it wouldn't matter, yeah.
There was a little handheld game, 21 questions, and like it would guess what you were thinking. Is that all this is? It's like that.
Yeah, we're gonna actually do that. It's an if statement basically that if you responded one way it would do one thing, and if you responded the other way it would do the other thing. But yeah, it is using all of this. So, I mean, I don't know what that game is, but I know what 21 questions is. So just to give you the syntax in MATLAB, the and uses the ampersand, I don't know if I said that right, symbol, and the or uses the vertical line. So that's the backslash symbol, the vertical line above. It's usually above the shift and return. So that's the syntax for the and the in MATLAB. So the logical operators get they're a little bit more confusing than the relational ones because those are pretty straightforward, but there's a couple different types of logical operators. So I'm going to show you some examples of this in MATLAB so you can start seeing how this works. But there's two ways to do these logical operators. So there's actually three because you can put the not symbol in front of anything and it can always just be the opposite of it. But when you have two in a row, so two ampersands or two vertical lines, this is basically the normal typical logical operator. So the way that they work is they're going to stop computing as soon as the result is known. So what this means is, especially if you have an or, if the first relational operator is true in the or, you don't really need to check the other one. So these will just skip the second condition if there's only one, if the first one is true and it's an or, for example. And this is known as short-circuiting. And this is sort of like the normal logical operators. This is how most of them operate in most programming languages. The alternative in MATLAB is the single symbol for each. And this is sort of like the vectorized operators. So they allow you to do comparisons on entire vectors. So short-circuiting would not be a good option because it needs to check each individual element by element. And I'll show you this example. Usually what most people do is they try one and it gives them an error, so they do the other one. But there is a reason for using one or the other. If you're just doing single elements, you can use the double. And if you're doing vectors, you can use the single, basically. Did you have a question back there? No. Yeah. Say it again.
Why is the totally global vectorized operation in the short-circuit operation?
Because it's always the opposite. So it just will be the opposite of the whole vector. So it just always reverses it, so you can use it either way. So the not isn't used alone. Usually, it usually just switches whatever the condition is. If that makes sense. So if you have a relational condition and you put a not in front of it, it just reverses it so that it's the opposite of whatever you put. sometimes it's more useful to think about it that way than to just reverse the relational to be the opposite. Okay, so we're going to move over to MATLAB so I can show you a few different things on this. So the first is a couple different examples. So I have 4 examples that I'm going to show you. So I'm going to set a variable a to 0. And I'm just going to create a logical statement, and you guys can look at it and see if you can read it and tell what the output is going to be. And this is a little bit to practice the double and the single, and a little bit just to practice what we just talked about with all of this. So this logical statement is going to check if a is equal to 0, or if 1 over a is less than 10. And remember that this is the short-circuiting option, so it's going to check the first one first, and if it's true, it's going to skip the second one. Does that make sense to everyone? So this whole operation is going to report back either a 1 or a 0 for true or false. So can anyone tell me whether this is going to report back true or false? So it's going to report back true, so b is going to have a value of 1. But the problem is that 1 over a is 1 over 0. So that's a problem, right? If you ever try to do 1 over 0, you get an error message or it gives you back infinity. So what happens when we do the single number? That's not what I thought happened. Maybe it's just the other one. Sorry, it's just the other one. So there's no difference in this case between the single or the double operation. Okay? Now let's do the second example. So the second example is that I'm going to create a different a, and I'm going to set it to 1. And it's an array, but only has 1 number in it, okay? I'm going to create another conditional. So this conditional is going to check if the first element of a is less than 0, and the second element of a is greater than 5. Did I do this? Oh, right, okay. So the double ampersand sign is going to check doing short circuiting. So the first one is false, right? The first condition is false. The first element was set to 1, which is not less than 0, so it's a false. So it already knows that the and statement is false. Does everyone see that? If I don't do it short circuiting and I have it check both, which is what the double ampersand does, the vectorized one will always check both, then you get an error message because it checks the second one, and the second one doesn't work because there's no second element of A. So that's just to prove to you that one is short-circuiting and the other one isn't short-circuiting. So why would you ever use the second one? That's what I wanted to show you. So the second one can be used if you have arrays that you would like to check the same condition for each element of the array, which is what you're doing in your lab. So I'm going to create 2 Boolean arrays. This one has trues on 1, 3, and 5, and this one has a true only on 1. So the AND symbol will compare, a 1 AND symbol will report back which elements both have 1s. Does everyone agree with that? Does that make sense to everyone? So only the first one was a 1 in both arrays. So it reports back a 1 in the first element, 0s everywhere else. So an example of how this works and how you'll use it in your lab is you're given a bunch of data, and this one is, what is this one? Trash tracking? Does anyone know? I think it's trash. Yeah, it's the trash lab. So I give you a bunch of trash, and then I tell you like how many years it takes for that type of trash to decompose, how much CO2 emissions get emitted from that trash. So each array tells you something different about the same trash, so the elements are matched up. So there's a bunch of conditions that you're going to look at to see if you can find the worst trash ever. And which is, if you were wondering, actually disposable diapers, but I didn't put that in there. you know, no ulterior motive of my conversation right now, but anyway, so what you can do is you can put conditions on each array individually with a logical in between. And so, like, I can say, I want to find the values of x which are greater than 2, but I also want to make sure the elements that match in y are greater than 7. So do you see how that's different than just looking at scalar comparisons? So what this will do is it will look and it will see that 3 and 4, the third and fourth element, are greater than 2, but only the 8 is greater than 7. So if you do the and, only the last element satisfies that conditional. And so you get an array that tells you which elements of that array match the relationship that you put in. You guys have any questions about that?
So when you use the double ands or the double ors,
Yeah.
why would you use those if it always doesn't even look at the second part?
Because logically you don't need to look at the second part. So if you have an or, if the first one is true, you by default don't need to look at the second part. But if you're doing that across arrays, MATLAB basically needs to know that so that it knows not to stop the whole array and it moves on to the next element. So there's just a different indication for that. Any other questions? Yeah.
Does MATLAB have an exclusive OR operator?
What does that mean?
One or the other, but not both.
Oh, it does. It's XOR, and I only know that because I just read the textbook. Yeah, XOR is what it is. Did you just read the textbook too?
No,
Oh, you just know. Well, I was about to congratulate you. Did anyone read that from the textbook? It is in the textbook if you look, if you have it.
Is it just typed out or is it?
It's XOR. It's a function. Okay, so I'm going to show you something from what you're going to do in the lab. So this is a really good example similar to your lab. So I'm going to list out a character string that labels each of the trash types. And then I'm going to create another array called years, which has data in it associated with each of those trash types. And so, for example, glass takes 50 years to decompose, etc. So each element matches. So let's just say that I wanted to find which elements had longer than 250 years to decompose. So I'll put in the conditional years greater than 350, and that will give me true and false statements for which of those elements are true based off of that relational statement. And you can combine relational statements, so you can have a bunch of and, ors, and relationals together. And then let's say, okay, that's nice to know the elements where those are true, but what if I wanted to know the actual values? What you can do is just plug the value, or you can plug the Boolean array that you just found back into the years, and then it will print out only the elements where it was true. Does everyone see that? And then, like we do in all the labs, is we kind of want to print out the back to the cell array. So you can also use this in the cell array. What did I call it though? Trash. And then it will print out. So cell arrays and arrays, they can read both the index locations like 2, 3, 4, as well as Boolean operators that turn on and off locations. They act the same way. So the find command gives you back element locations, and logical indexing, which is what this is here, gives you back zeros and ones, but they're read by the array the same. They do the same thing. They'll just give you back. So the last thing that I wanted to end with is mostly going to occur in the next topic, but we are going to deal with it just a little bit right now because it's kind of a natural introduction. We already talked about it a little bit, which is the if statement. You're going to practice this a little bit in the pre-lab, but you're going to do it a lot in the lab 5. So you don't need it for the lab though. So you can use it in the lab, but you don't need it. So if statements are decision-making structures that use logical and relational operators. And you basically can barely write any code without an if statement. So the way if statements work is they're a way to check conditions that you make with logical and relational operators, and then only execute commands if the statement is true. So the most basic syntax for an if statement is you type if and end. They'll turn blue because they'll be recognized as the if statement. And then the condition, the relational condition, goes behind it. And then anything you want executed is going to go in between the if and the else. So that's the most basic if statement. You can also do if-else statements. If-else statements, you have the if, but then there's an else before the end. And the if statement gets executed the same. It'll get executed only if the condition is true, condition 1.
Where does that say right after your if there?
Condition 1, but it's spelled C-O-N, shortened it a little bit. And so anything in the else statement gets executed if condition 1 is not true. So in some circumstances, the else is all you need because you just have a condition or anything else. And then the only other option that we use is the if-else if clause. So that is if you want multiple subsequent conditions to be checked that don't overlap. So an if-else if clause will check condition 1. And if condition 1 is true, then those commands in between get run. But the else if is going to have a second condition, condition 2, that's going to be executed if condition 2 is true.
What would happen in that second case if the command 1 was false and you just had else?
Then it would go to the else.
What is the else?
There's nothing. It's just anything else than other than that condition being true. So if, sometimes it's just blank. It just depends on the logic. So I got 2 minutes, plenty of time to show you a little example. Don't worry, won't go over. I'm gonna write a quick script. So I'm gonna write an input function, and this is a really important, very useful code that all of you will probably use at home. So let's say I ask the user, what is 2 plus 3? And then I want to help the user by giving them some feedback on whether or not they got their answer right. So I could say that if they put the right answer and said that x equals 5, I could say, good job, you got it right. And then if they got it wrong, I could say, whoops, wrong, and then end it. See if it works. What is 2 plus 3? 6. Whoops, wrong. So you take it from there. What's up?